Hello, and welcome to a chapter on the industrial and enterprise networking. So, in this chapter, we are going to identify the significant components of an industrial control system or the SCADA system, which we'll discuss in details. We'll talk about the inventory and manage network assets and be able to identify the significant business documents. And we'll talk about the change management, physical security controls, describe the different components of a disaster recovery and forensics. Um, all of that will be discussed. All right, so an industry, by the way, you're going to be writing a little bit more in this chapter because a lot of this stuff are important to remember. We're going to be talking about, this is a typical different than the data communications lands that we've been discussing earlier. Anyway, so just be prepared to write a little bit. A lot of this is informational. Well, all of it is informational, of course. Anyway, the industrial system is when we're talking about an industrial system network, it's a system of machines, such as assembly lines or drill bits that are controlled by a computer that are pre-programmed to do something. So all of those computers interact with machineries and physical components that are not digital or technical in nature. The Internet of Things, for example, could be you have video surveillance cameras, your refrigerator, your HVA system could be connected to a specific network that you can control remotely. So these are not really, they don't pass data. They need data to be given to them to operate in a certain way, right? So all of these are industrial networks, devices that not necessarily communicate with each other, but they may be able to communicate with each other, but they probably go to one server and the one server tells them what to do. All right, so there are two things that I want you to write down. The industrial control system, which is a group of networks, we'll write this down, group of network computers used to manage physical system or industrial processor. The basic components of ICS, I also want you to write that down, is the SCADA, which stands for Supervisory Control and Data Acquisition, the remote terminal units, the programmable logical controllers, the PLCs, the communication channels, and the human machine interfaces, the HMIs. All right, so once you finish writing those down, the basic components is to an IS is the software also, and the IS servers, which is very important. The acquisition servers. These are the ones that have an input-output service that communicates with the devices that are connected. They they take data and then they process that data for you. All right. So here's a typical SCADA network. So all of these devices, they gather a field location RTU PLCs. So they get information from this acquisition server and this how they run, depending on who you are. They all go to a acquisition server to get all the data from. A PLC, for example, like such as this, they control belts in an assembly line. Um, and these are very, very big. You use ladder programming. I've taught a course on PLCs where you can, you know, um, traffic lights are controlled with them. Um, if you can control opening windows, closing windows with PLCs. They have relays that can send a specific amount of voltage to a device that can enable pumps to pump water, traffic lights, like I said earlier. Uh, I remember belts. I think I used Mitsubishi's PLCs. In industrial, you control all of the equipment usually using PLCs. They're pre-programmed and they operate depending on what that PLC system is telling them what to do. There are two methods that an ISC might use to control the physical system. So please write these down as well. The open loop system and the closed loop. Open loop, that means they make decisions on predetermined expectations, events, or past history. So they already know what to do. They're pre-programmed and that's an open loop. And they decide, and they can, and the system will operate depending on what they've been told and what the expectation is. So they don't have necessarily even to be programmed. So if after a certain level, they'll do certain things. Now, closed loops may, they have to be told in real time what to do. So they required field devices distributed throughout the physical system to monitor aspects of the system. So open loop, meaning it's not in real time. They already know what they need to do. Nobody needs to tell them anything. They make up their own decision. Closed loop, you have to be told what to do, the machine that is. All right, so the recommended best practices. So please at least write these 5 points when you're setting up or working with ICS and SCADA networks. Inventory of all connections have to be done. Segment your network from the corporate network. It has to be, you don't want your assembly where all the warehouse work connected to the corporate network. That might create an issue. Isolate your network and placing it in a DMZ zone. If it from the corporate network, you can still control it, but it's outside. So in case something goes wrong, disconnect the network from the internet. That's very important because if it's connected to the internet, they can, the cyber criminal, cyber terrorist may get in there and apply certain amount of voltages that can disrupt, you know, pumps and things like that, or electricity, and they can harm your connection. So don't connect any of the SCADA ICS network to the internet. It's very important, especially if it's controlling big machineries. You can harm the machineries or do damage to your network and to your work. Viruses or anything can easily be attacked. Now, if you are isolated from the internet, that doesn't mean you may not get an attack. Your employees, you may get attacked through a USB drive. Somebody can, bring in a USB drive that is infected, and they still will attack your internal SCADA network. Will make the pumps. For example, if you have a network that is generating electricity, and if that generator is connected to the internet, it could be attacked, and that generator could be disabled very easily. But if you disconnect it from the internet, the likelihood that that's going to happen, it drops to zero. But somebody, one of your employees can bring in an infected USB drive that connects to that generator that could be harmed. So you got to be able, so you got to secure it that way as well. Secure and harden the ASA network by implementing strict firewalls and IDS systems and physical security controls, like making sure that if you allow USBs connections to your devices, they have to be scanned, right? Make sure you have fault tolerances and deploy redundancy, of course, just in case something goes wrong. All right. Harden the network by controlling access to the network and with encrypted authentication. Protect the historian. Make sure vendors are responsible for supporting the hardware and the software of the network, and so on. All right. So all of this you should really know, and you should write down all the recommended practices. So if you ever been employed, so I want you to write down these notes as well, and these notes, because if you were ever hired in a company where you are responsible for an IES network, all of these best practices you should know and recommend. So you'll know, you'll be trained on how to operate all of these different machineries, the PLCs, but the best practices has to come from you. For example, you need to keep all the documentations needed for the configuration managers. You have to be organized, right? Keep well documented and well maintained backup systems. Everything has to be backed up. Clearly define the risk management practices and implement a role-based RBAC to the system. Remember, depending on who you are, you can have access to specific devices, resources. And we've discussed that in a different chapter, if you remember. All right, so asset management and business documents. The asset management document is very, very important because you want to make sure everything is documented. All the assets, all the inventories have to be there. So you want to refer to monitoring and maintaining all assets that make up the network. So you got to take inventory of all the network components. Well, that's true for anything, everything. What are those assets? The hardware, software, what they are connected to. You need to determine the appropriate asset management tool. How you're going to manage all of these assets. Who's responsible for what when something goes wrong. Because you want to keep track in case something goes wrong. Do you have backups for any of them? Whose responsibility, who to call for to fix any of these if there is any issues, how they are connected, how they are secured. All right, that's all have to be documented. All right, here's also I want you to write the following standard business documents that you should be familiar with. The RFP, request for proposal. When somebody is proposing something, they're going to send you an RFP to accept it or not. A memorandum of understanding. This is just a document to indicate the intentions of what you guys agreed to. An SOW, a statement of work. So if you agree to a specific, they're going to send you a statement and say, this is what we're going to do for you, this, and that. You may have an SLA, a legally binding contract that you have to sign, and if you signed it, you have to meet that contract with the SLA. And if you don't meet it, if you have to pay a certain amount of money for a certain amount of service. So if they didn't do the service, they may breach. This is like a contract that you can actually take to court if somebody does not breaches the contract. MLA, a master license agreement. If somebody gives you, especially for software, a creator allows you to use their software or whatever they did produce for you. That's an MLA. You want to have that so you can. Somebody comes in and says, "Hey, you're not supposed to be using my software or my patent." So this way, you'll show them the MLA that you're paying for it. Actually, you typically pay for an MLA. All right, change management. What happened if you need to change devices, upgrade something? You got to keep track of all of that. If you upgrade a hard drive, if you upgrade a machinery component or whatever, you need to keep track of it. And how do you keep track of it? So you have to have a plan on how you're going for the change, for the management, for the change. How do you manage the change, right? Software and hardware changes have to be, because imagine that everybody's upgrading and and even downgrading software and hardware and you have no clue what's going on. Not good. So you need to know exactly what's been updated when and what changes. So you keep track of it, right? That's very, very important. There are two ways that you could do. Three types of changes in software. I want you to write this down. You can use a patch. You got to make sure what patches you have installed. Write those down. Upgrade, if you upgraded an operating system or an applications. Rollbacks. Now, before you do an upgrade, this is something that I want you to remember. You should also always back up what you need to upgrade because there's a good chance that you may have to roll back and go back to the old system because the new operating system or the new applications does not work properly with some of the equipment. So you may have to roll it back. I've done it several times that a specific operating system did not work properly, and I have to go back so that my software can still work in the old operating system, for example. All right. So make sure that you are able to do that in case that ever happens. So before you start upgrading, you back up everything, right? Because something might go wrong. For changing software or hardware, please write these points down as well. Don't allow patches to automatically install unless it's a security patch, right? For the operating system, typically Windows will do that automatically. Usually they're downloaded and they'll let you know they're ready to be installed. Um, Security patches for operating system and applications, I highly recommend that you install them automatically. If you don't and you wait and there are vices floating around, so you may get hit. Determine whether a patch or upgrade is necessary. That's a good point, by the way. What I usually recommend, if the upgrade is just to give you some new features that you really don't need, don't bother with the upgrade. If everything is working fine and you don't need the upgrade, then don't do it. But if the upgrade is needed for efficiency, for speed, for security, and you think is it can you can be more productive with it, then go for it. But if it's really just for a looks or something that you don't need and it's really going to disrupt your work and it's hard, because and it needs you need to train people to do it, don't bother. I've known organizations that they stayed with an operating system on for their employees as long as they can go till applications started coming out where they cannot be installed on the Windows 2K, I think it was. So they were forced to upgrade to Windows 7. You know, why upgrade when everything is working fine? Um, as long as security and everybody is working and no complaints, then you're fine. Um, Research the change purpose compatibility, right? Because if you need to upgrade an operating system, make sure all the devices will operate under the new operating system. Otherwise, don't bother. But if you did upgrade, make sure you're ready to roll back. Test the patch or upgrade in a testing lab if you can do that. You should definitely do that before you go live. Determine whether the changes should apply to all users, network segments, or devices. Does everybody need the upgrade or not, in other words? Schedule the change for completion during off hours. Of course, you want to do it on a Saturday night after midnight into Sunday where there's nobody really having any access. All right, also, write this down. Notify appropriate personnel of intent to change. In fact, write all of these points down. This is important not only for a SCADA or an ICS system, but also for a typical um, corporate network. Back up the current system that you have. Prevent users from accessing the system during the change. Well, if you're doing it off hours, you should be okay with that. And by the way, let them know that there's going to be an upgrade and users will not have access to the system for a certain amount of time. Keep instructions handy when you're installing the revision. Implement the change and test the system before you go live. Re-enable access to the system. Inform personnel, like I said, that the change is complete and now you have access, right? Record the changes. Documentation is very important. All right. Reversing a software upgrade. You know, expect to do that. Again, make sure that you have backup before you do that. Back leveling, right? Go to a previous version because the new versions did not operate well with the connected devices. You may have to do that. And a lot of time you do. But if you do your homework and check out this new operating system that you're trying to upgrade, does it work with does it have the device drivers, right? That enable you to connect, that will make sure everything will be working fine. You know, how many times you installed or upgraded a new operating system and certain things did not work properly, and then you have to go and download new device drivers. Make sure if you do your homework, you should not have any problems. But even after you do all your homework, something might go wrong. So that's why you need to back up the original older version before you do your upgrade. All right. So change management documentation, but make sure everything is documented, and you should be okay before and after. Physical securities. So let's talk about physical securities. Um, Make sure, depending on the labs and the equipment that you're working, make sure that only authorized users have access to specific locations or devices physically. For a network room, no one should have access to any of these devices because you can remotely access them. If you are in a SCADA system or an ICS system, only the trained employees should be at those devices or operating them and have access to them. They should have either a badge or a biometric authentications or even just a regular username and password to have access and control these devices. It's very important. Don't just allow them to be controlled by anyone. No one should have access to control a PLC, for example, a programmable logical controller. You could do harm. You should have some security um, in place for anyone to have access to any of these devices. Doorknobs, for example, cipher lock is, you don't need keys. Especially this is important if you have, employees that are coming in and out, temp employees. They're not going to be here for, say, they're only going to be here for a year or two. So you don't have to keep changing locks. You just change the combinations, the pin to get in there, and they're pretty secure, right? Um, Badges that you need to come into rooms, and depending, if this is the day room, you can need another badge to come in. This is something called like a man trap. No one will have access to the data room without having to go multiple rooms. So when you come in here, you'll need another badge. You need another scan to get into the data room, right? So you can have biometrics by scanning your thumb, even your eye retina, face recognition. You could do that. Man traps means you don't have directly access to the devices. You have to go into like an area and then another. For example, let's say your data room. What you do it in the back. You'll have a door there to get access into the network room, the data room, and your office will be in that one room. And to get into your office, there's going to be another patch. So you have to go into your office, and from your office, you'll go into the data room. Your office will be the man trap, right? Advanced imaging technology can be used to scan your body to see if you have anything, right? You can scan your finger when you go into, uh, you know, into any places, even carnivals or anything like that, where they scan your finger to identify who you are. They have these at airports, right? If you ever went to an airport, they'll use those physical scanning, the ATI scan. They use video surveillances. You can use that. Cameras that go outside or inside, making sure, you know, it's been said every day, one way or another, there are 18 cameras that took pictures of you nowadays, outside, inside, in supermarkets, in parking lots, in your university, Probably the only place that you don't have cameras is locker rooms and restrooms. One way or another, somebody took a picture of you. And now with all of these ubiquitous cell phones, they are everywhere. Any altercations, you've probably seen it on the internet. Somebody has taken a picture of these altercations and they go viral, right? So there's plenty of surveillances outside. You might want your own to keep track of who's in and out of the network, outside and inside, of course. So physical security is extremely important. No matter how well you secure your network and your devices logically, software-wise. If people have physical access to those devices, those logical devices don't make, doesn't make any sense then, because they can actually physically break or steal the equipment or the device that you're trying to secure. So physical security comes first, actually. Only limited people should have access, and you should track these people that have access to the network room or to those devices. All right. Here's another thing that you should know when it comes to getting rid of PCs, desktops specifically. The hard drive is the one that you need to worry about because that's where all the information is. So you should take out your hard drive and just discard the whole box. Don't throw it in the garbage. Just take it to your recycling place in your city. With the hard drive, you can use a degausser. That's a magnetic hard drive that just removes all the data because typically the hard drives, the electromechanical hard drive, the one with the arm, it uses an electromagnetic field to place data, and the degausser just removes all the data. So you could do that. That may be a little bit costly. You can put a nail through the plates if you want, but don't throw out the hard drive because even if you erased everything, even if you formatted everything, there's ways of getting the data that's on there. So if you have something that is sensitive and you do not want anybody to see it, passwords or whatever, and even if you got rid of them, um, and somebody wants to know what's in there, they may get to it. So physically damage the hard drive before you before you throw it out. These disaster recovery plans. Okay, so if you work in any organizations, you have to have a plan if something goes wrong. If something goes wrong, not only to your system, but to the physical plant that you work at. So what happens if there is a hurricane or a tsunami or blackouts? How can your employees operate? Can they move to another place or not? Right? And they have to be trained, especially if you are in a location where um, hurricanes may be, right? A business continuity plan to be able to set them up so that the business can continue in case there's a problem. So you have to have that. So in addition, please write this down. Restoring critical functionality of data in a disaster recovery plan, DLP it's called. Uh, you have to be able to restore data as quickly as possible, and um, and it has to be documented, and employees have to be trained on how to recover data and what to do in case there's a disaster. You have to, um, if there are security breaches, you have to be able to consider the possibility of the extremes in case the whole enterprise network outage. Nobody has access to anything. You can't access the building because something happened in the building. Can they go work something somewhere else, or can they work from home? You got to be able to take care in case there are failures, security breaches, data corruptions. You gotta look at all of that and have some backups. Think of all the worst case scenarios and what are you going to do? There should be a team that is responsible in case there's a disaster, and that team should, manage all the DLPs, the disaster recovery planning. Provide contingencies plans for restoring and replacing computers, power, telephone systems, everything, right? All of that has to be in there. In the plan, you should contact for emergency coordinators, the police, the fire departments, the supervisories, where we're going to go, and all the people from the top has to have a plan, and already the decisions should have been made on way to move in case there's a disaster. Details on the network topologies, the redundancy and the agreements with the national service carriers. Regular strategies for testing disaster recovery plans you should implement. All right, write these down. The three, especially for sites, the three contingencies that you should take. You have to have one of those three. You can have a cold site. So please write that. That cold site is just an open room, open space that your employees can move into and do their work, but then they have to bring in their computer. It's going to take a little while. They have to bring in everything. There's just a space. You may have a warm site. A warm site is you have all the equipment, you have the computers, but it's going to take a little little work to bring you back up to running. A hot site, maybe another room that you can go in and immediately use that room to do your work. They got everything for you and you just need to show up. For example, let's say a classroom that has lost internet connections and you do a lot of work on these computers. They can move you to another classroom that has computers and has all the software and resources that you need. So that other classroom would be a hot site. Or you could do it from home, right? A lot of people try to do the contingencies. If you lost connections, this is what you should do for the next couple of weeks. And and you got to keep your employees updated about what's going on. All right, forensics. So forensics is, please write this down, defines the characteristics of an event that qualifies as a formal incident and steps that should be followed. You're trying to glean over all the evidence and find out what happened. All right, so what happens? A break-ins, a fire, weather-related emergencies, hacking attacks, discovery of illegal content or activity. All of these, you need to glean over exactly what happened and how it could be prevented. That's why you need to do that. Okay? So forensics are important. So if there's a breaking, for example, you need to find out how did that breaking happen and why did it happen? If there's a fire, how did we prevent it? Did we have fire extinguishers? Or why was there a fire? Why weren't we protected? Or anything like that, right? You cannot prevent all accidents, but if you are aware, you want to minimize the problems. And even if it did, even if a problem occurred, you have some backups. You have some fault tolerance in place. So the data collected might be presented in court, of course. You want to be, in case there's a break-in or something that is done illegally, and you gathered all these you create what's called a chain of custody. All the evidence that you can prove that a break-in happened and this person or that occurred, and it was done illegally. So you have to protect all the evidence to show in court or to prove to the human resources that this specific employee was doing something illegally so they could be, reprimanded. This is very important. So, and you got to keep track, and this way you can protect yourself. You learn from the attack or from the problem that occurred so you can actually mitigate issues that can, prevent this problem from happening again. All right. So a response policy should detail the following steps. This is really the steps that you should take, and I want you to write down for forensics. Determine if escalation is necessary. You need to take this up to the upper management if it's a big security breach, for example. Secure the area. Document the scene. You can take pictures, write down exactly what's happening. Monitor the evidence and data collections. Everything that you collect, look at it carefully. Protect the chain of custody, all the evidence. Make sure no one tampers with it. So in case you need to present it, for example, to court. Monitor the transport of data and equipment. so no one can tamper with it as well, and create a report of exactly what happened. Take pictures if you need to, right? Just like a detective. Uh, the members that should be working in the response policy, the dispatcher, the manager, the technical support specialist, public relations, and so on. All right. So that's that for this chapter. Please write down everything that I told you, and submit them as your homework. All right. So I'll see you guys later then.